Okay. Well, let me just ask you a few questions if you know them. Do you know question 25?
Oh yeah, that one. Put that in the list of interesting and not really.
Okay. And what about 23? Is it interesting or challenging?
No, I'm good.
22?
No.
Okay. Well, then let's start. So first question. Harrison, do you want to start off by explaining question 11?
Okay.
Okay, and also, so when I started sharing screen, do you see, like on the top, there's this bar called Qixin started sharing his screen, and then you view options or whatever it's called. You just go into options, and then you do annotate.
Oh, so I can also write.
Try and write.
Yeah.
Oh, okay, you can write. All right. So so we can do the first problem. All right.
Okay. So I first found the pattern for the example the question gave, which is 1, 1, which is 1, 1, 2, 3, 5.
Yeah.
And then I thought that like probably the example that the question gave us would probably mean that they're probably giving us a hint of what the answer would be. So I found the pattern rule, which was the first two numbers, when they add together, it makes the next number. So 1 plus 1 is 2, 1 plus 2 is 3, and 2 plus 3 is 5.
Yes. And then, so
So
what's the
they
next?
already gave us a starting point, which is 8. So I pretty much did the same thing, the same pattern rule. Yeah.
Okay.
Wait, no.
You want me to draw?
I don't know what happened. Like, I somehow can't write.
Okay, wait. Then I'll draw. Wait a sec. Just 1 sec. Here we go. Okay. So, I'll just help you explain.
Okay, yeah, it works now.
Oh, it works? Okay.
Yeah, I have no idea what happened just then, so.
Are you writing? Are you attempting to write? Oh, never mind.
Wait, can I just ask a question?
Yeah.
So, you're basically saying here that 1 plus 1 is 2, 2 plus 5 is 5. But 2 plus 3 is 5. And then 3 plus 5 is 8. And then 5 plus 8 equals 8. And 8 plus 8 equals 16.
I think Harrison misunderstood the question as something else. He thought that this was a type of pattern, but instead of starting with 2 1s, that we were supposed to start with 2 6s. That's totally okay. Like that's not a wrong answer, but contests, you want to follow what it says and you want to read like what the problem is.
Okay.
Yeah, so this isn't wrong. Like you could start with 8 and do the Fibonacci, but like what we can but what this question is asking, it's asking which of the following numbers is in the Fibonacci starting with 2 1s. So we have 1, 1, 2, 3, 5, 8, 13, 8 plus 13, 21, and that's what it means.
Oh, I see. Okay. Well,
Yeah,
then I probably
okay.
misunderstood.
All right. Yeah, that's okay. It's okay to make mistakes. All right, so number 11 is done. Now, question 12. Question 12. The grade 7 class at Gauss Public School has sold 120 tickets for a lottery. One winning ticket will be drawn. If the probability of one of Mary's tickets being drawn is 1 in 15, how many tickets did she buy? So, we have 1 in 15, and there are chance, and there are 120 tickets. So if we have, so we know that if you only had one ticket, you would have 1 in 120 chance of winning the lottery. Because since all the tickets have an equal chance, all the tickets are 1 in 120 because it splits evenly between 120 tickets. So now we have 2 tickets. For example, if you have 2 tickets, then you have 1 over 120 plus another 1 over 120, which equals 2 over 120. So if we continue doing this, and like for example, we have in tickets, then the chances of you winning the lottery is n over 120 if n is smaller or equal to 120. So then we see that n over 120 equals 1 in 15 because this is the chance. And then we have, so wait, one sec. So now if we multiply 15 on each side and also multiply 120 on each side, we get 15 n equals 120. And then we divide 15 on both sides. 120 divided by 15 equals 8. So is this clear? Which means that n is 8, and the number of tickets Mary bought was 8 tickets. Is this clear? Does everybody get it?
Yep.
Okay. And now we go on to question 13. Question 13. What is the largest amount of postage in cents that cannot be made using only 3 cents and 5 cent stamps? So does anybody want to explain this? Can anybody explain this? No? Okay. So we have 3 cents and we have 5 cents. And it's asking what is the largest amount of postage in cents that cannot be made using only 3 cents and 5 cents. So one strategic way we can do it is we can go from the largest answer to the smallest answer. So we have 13, 9, 8, 7, and 5. I mean, not 5, 4. So 13. Can we make 13? Somebody say yes or no.
Yeah.
Why not?
What?
What? You said no.
Well, I said yes.
Oh, okay. Then never mind. Wait just 1 sec. Okay. So, oh, okay, never mind. My bad. All right. So, you said yes. Why so?
Because you can use 2 5 cents and 1 3 cent to make 13.
Yeah. So we crossed it out. And what about 9? Well, we can form 9 with 3 3-cents. We can form 8 with 3 cent and 5 cent. Can we form 7? Well, if we use only 3s, we can't form 7. 7 is not a multiple of 3, and it is also not a multiple of 5. What about 3 and 5s? 3 plus 5 is 8. So we know that if we're using 3 and 5 to form money, then it has to be larger or equal to 8. So 7 is our answer. Okay. Now, question 16. Okay, Sean, can you explain question 16? And would you like me to draw on the whiteboard, or do you want to draw yourself?
I can draw myself.
Okay, do you know how to?
Yeah.
All right.
Okay, so let's just draw this. And then this equals to 8.
Mm-hmm.
Okay, so if you look at the first two, the second one has one extra circle than the first one. And the difference between these two are 3. So then you can just conclude that circle equals 3. And then if you look on the first one, let's say square is x plus 3 equals 8, then square equals 5. And then and then two triangles equals to 12, because you know, and then so that means one triangle is 6.
Okay, thank you. So the answer is 6. I think that's pretty clear. And then we have question 19. Wait, 1 sec. Question 19. Okay, so question 19. The whole numbers from 1 to 1,000 are written. How many of these numbers have at least 2 7s appearing side by side? So, first off, we want to clarify some confusion if there is any. If we have 707, 708, there's a comma between the 2 7s, so they're technically not connected. That's just a clarification. And now let's start. So in a number, there must be 2 7s that appear side by side or more. All right, let's look at 1 digits. Well, 1 digits only have 1 digit. So like you can't have 2 sevens in a 1 digit. And let's look at 2 digits. Since 2 sevens are 2 digits, then that means the only 2 digits that have 2 sevens beside each other is 77. So that's one of them. And then we have 3 digits. So for 3 digits, we can have 2 sevens in the front. So we have the last digit could be 0 up to 9. Or we could have 2 sevens in the back. So the first digit is 1 to 9. And then, of course, we can have 3 sevens. But the 3 sevens is already included in this and this category. Alright, so keeping that in mind, let's add the amount together. We have 1 plus 0 to 9. How much is 0 to 9? That's 10 numbers. Plus another 9 numbers. Plus, no, not plus, minus, because since 777 repeated twice, we have to minus it one time. So that we have one 777, but we cross out the other 777, which this equals 19. Okay, do you guys get it?
Yeah.
Okay. 19. Oops. All right, and now we have 24. In the multiplications shown, P, Q, and R are all different digits, so that PPQ times Q equals RQ 5Q. And it's asking what's P plus Q plus R. So first off, in this problem, what we need to do is we have to look at attributes of the digits. Right off, we can see that we have Q times Q equals something Q, 2-digit number. So what does this mean? For example, we have 0 times 0 equals 0, 1 times 1 equals 1, 5 times 5 equals 25, and 6 times 6 equals 36. There are no other digits that that their square ends in the same digit as the digit, which means in this case we have 6 times 6 equals 36, and 5 times 5 is 25, and so on. All right, so what if Q was 0? If Q was 0, there would be no 4-digit number as the product. It would be 0. So we can cross that out. What if Q was 1? Then the product would be PPQ, a 3-digit number, which we can cross this out. And then we have 5 times 5 equals 25. So let's try that. If Q equals 5, then we can have wait, one sec. Yeah. 5, 5, 5, 5. So we have 5 times 5 equals 25. And then 5 times P equals something that ends with a 3. Because this way, 3 plus 2 would equal 5. But what's the rule about multiplication with 5? The rule is any integer multiplied with 5 will end in something 0 or something 5. But it cannot end in something 3, which means that this is invalid. Now, what if we have Q equals 6? So we have P 6 times 6 times P 6, 5, 6. Wait, this is not P, this is R. Okay, so we have 6 times 6 is 36, and then 6 times P will equal something 2. So what times 6 ends with 2? Think of a number.
7.
Yeah, 7. So we have 6 times 7 equals 42. If we have 7, then the p is 7. We have 42, this is 5, this is 4. 6 times 7 is another 42. And 42 plus 4 is 6. So now we have 4 here, and 6 times 0 is 0. 0 plus 4 is 4. So r equals 4, q equals 6, and p equals 7. And if we add them together, 4 plus 6 is 10, plus another 7 is 17. All right. Now question 25. Question 25. The CMC reception desk has a tray in which to stack letters as they arrive. Starting at 12 o'clock, the following process repeats every 5 minutes. Step 1. 3 letters arrive at the reception desk and are stacked on top of the letters already in the stack. The first of the 3 is placed on the stack first, the second letter next, and the third on top. So 1, 2, 3. And then step 2, the top 2 letters in the stack are removed. Now we have 1, and we have the discard pile of 2 and 3. Okay, and this process repeats until 36 letters have arrived. So we have ... all the way to 36 arrives. And once all 36 letters have arrived, no more letters arrive, and the top 2 letters in the stack continue to be removed every 5 minutes until all 36 letters have been removed. At what time was the 13th letter to arrive removed? But first off, we're going to see if 13 goes directly into the remove bin, or does it stay in the pile for a while. Okay, so we have 1. 1 is in the pile, 2 and 3 are in the remove bin, 4 is in the pile, 5 and 6 are in the remove bin, and etc. So 7, 8, 9, 10, 11, 12, 13 is in the pile, which means that we'll have to remove it later. So first off, we have to calculate how long it takes for all 36 letters to arrive. We start at 12 o'clock, and by that time we already have 3 letters. And every time 3 more letters arrive, we have to plus 5 minutes. So the question is, how many 5 minutes do we have to add? Now, since they're in groups of 3s, how many groups of 3s are there in 36? There are 12. But remember, the first group of 3 came immediately at 12 o'clock, which means we can't count the first group. And now we have the other groups. So we have 11 times 5 minutes plus. Okay, so now we have all 36 letters have arrived, and the 36th and the 35th letter were removed. So now it says every time from the top of the stack, which is 34, they remove 2. So 34 all the way to 1. So we have 34 and 31, and so on. So how are we going to calculate this? We calculate all the way to 11. First off, I'm going to erase these things. Okay, so we first off have to get to 13. So we have 1, 4, 7, ... all the way to 34. And we remove 2 each time. We want to figure out how many times until we remove 13. So what we can do is, because there's a gap of 3, which means that 4 minus 1 is 3, 7 minus 4 is 3, we can add it to be multiples of 3. You'll find this easier. What I mean is, if we add 2 to all of these numbers, we get 3, 6, 9, all the way to 36. All right, so how does this help us? This helps us because we can simplify the list to 1, 2, 3, all the way to 12. So we have 12 letters in the pile, and we remove 2 by 2. So we have 12 and 11, 10 and 9, and so on. So, and what is 13 going to turn into? So 13 plus 2 divided by 3 equals 5. And how many letters are there between 5 to 12? Well, 5 minus 4 is 1, 12 minus 4 is 8. There are 8 letters between 5 and 12. And every time, since we remove 2 letters every 5 minutes, it takes us 4 or 5 minutes to remove 8 letters. So now what do we have? So we have 11 fives plus 4 more fives, which means 11 plus 4 is 15, 15 more 5 minutes. How much is, somebody tell me, how much is 15 times 5?
75.
75.
75? Yep. So, which means that 75 minutes pass. So we have 12:75, but that's not a time. We go up to 12:59, and when it's 60, we go to 13:00. Which means that we have to split it into 60s. So we have 160 plus 15, and we get 115. Okay, so that was a lot. You guys can, I'll give you like 1 minute to think about what I just talked about. All right, question 23. We're working backwards now. Question 23. Can somebody read the question to me?
A square is divided as shown. What fraction of the area of the square is shaded?
Yeah. What is the shaded area? And what does these marks mean on the square? These marks. It means that these two lengths are the same. So, first off, let's just say the square, the entirety has an area of 1. So if we have the shaded region's area, let's say AS for area of the shaded region divided by 1, it'll equal AS. So all we need to figure out is the area of the shaded region. And then since the side lengths are 1 for the big square, then the fraction of the area of the square which is shaded is equal to the area of the shaded region. This way it's easier. So we can first split the square in half. So this is 1/2, this triangle. And then we split it in half again. This is 1/4. And after that, we can do something. Draw a line up to here. So first off, I'm going to erase some stuff. And we drew a line up there. So these two triangles are the same. And if we do this, these two triangles are the same. So for example, we have any isosceles triangle, and then we split it by the midline. Well, not any isosceles triangle. Well, see here, if we have the same triangle as this one, this is a 90-degree angle, this is 45 degrees, this is also 45 degrees. So it's right isosceles. And now we see that these two triangles are congruent. And since these two lengths are the same, and this is 45 degrees, this is also 45 degrees, this is 90 degrees, since the sum of all the angles in a triangle, on a straight edge added together is 180 degrees. Which means that this is also congruent with these two triangles. And it's the same case with this one, it's also congruent. Okay, that's just a quick explanation of what was happening there. So we have 3/4, 3/4 of this triangle. And how much is this triangle? It's 1/4 times 1/4 equals 3/16. And what did we say earlier about the fraction of the square that is shaded? Since we have the area divided by 1, which is a fraction, anything divided by 1 is equal to itself. So the fraction of the area of the square is shaded is 3/16. Okay. So question 22. The average of 4 different positive whole numbers is 4. If the difference between the largest and smallest of these numbers is as large as possible, what is the average of the other two numbers? We have A, B, C, D, and their average is 4. How do we do this? So it's saying if the difference between the largest and smallest of these numbers is as large as possible. So let's say A was the smallest, B was second small, C was third small, and D was the largest. It means that we want A to be as small as possible and D as big as possible. So if A was to be as small as possible and it was a positive whole number, that means A would have to be 1. And then after that, we want D to be big as possible. So what we can do is we want to make B and C smaller. Because if B and C are big, that means D would have to be quite small, since there's a set average of 4. So let's just make B and C the smallest they can be, and they have to be different. So we have 2 and 3. And then after that, we have to find out D, in which the average of the numbers will equal to 4. Well, do we really need to do that? Let's just do it just in case, just to be safe. So we have 1 plus 2 plus 3 plus D divided by 4 equals 4. And now if we multiply 4 on each side, this becomes 16. And then we have 6, this is 6. 6 plus D equals 16. And D equals 10. D is 10. But it's asking the other two numbers, so B and C. So the average between 2 and 3 is 2.5. Do you guys get the question? All right, 21. 21. Basically, you just have to follow the arrows and then you have to make out the word carol. L, 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 L. Okay, so how are we going to do this? So let's first look at the starting position. K is the starting position. We only have one possibility for the starting position. And then we can branch out into 2 different places. So we multiply 2 more possibilities. So from each of the different places, we can go to 2 more areas. And to the 2 more areas, it's times another 2. And then from each of the 3 areas, somebody said something in the chat. Yeah, I did miss the L. You're right. Okay, glad you're paying attention. So we have 3 R's, and then it branches out to 4 L's. Each R branches out 2 times, which means we multiply another 2. So you have 1 times 2 times 2 times 2, which equals 8. Question 22. What was the question to question 22 again? It was 2.5. Okay. Now, moving backwards, we have question 20. One sec. Okay. Question 20. Can somebody read question 20 for me? All right, question 20. In the diagram, the square has a perimeter of 48. So that means its side length is 12, since 12 times 4 is 48. And the triangle has a height of 48. And then if the square and the triangle have the same area, what is the value of x? All right, so we know that for the square, the area is 144, which is 12 times 12. We can just write it as 12 times 12 right now, because it'll be easier later. So we have x times 48 divided by 2 equals 12 times 12. We see that 48 is actually 4 12s together. So we can divide a 12 on each side. We have 4 over 2, x times 4 over 2, which is 2, equals 12. And x equals 6. Which means that x is 6. And question 19. We already did that. Question 18. Fred's birthday was on a Monday. So we have Fred on a Monday. And was exactly 37 days after Pat's birthday. And then Pat's birthday was 67 days before, and Pat's birthday was 67 days before, no, not Pat's. Julie's birthday was 67 days before Pat's birthday. Julie. So it's like a timeline. So we're going from the past to the future. Just imagine this. Yeah. So first off, we have Fred's birthday, and Pat's birthday has a difference of 37 days. And since we're looking at the day of the week, we know that if we subtract 7 days to our days of the week, then that means we go back to the same day of the week. What I'm talking about is, for example, let's say today was Wednesday, and 7 days ago minus 7 days, it was still Wednesday. So all we need to do is we need to break down 37 days into sevens. So how many sevens are in 37? Somebody tell me.
5.
Yes, 5.
Major 2.
All right. So we have 5 sevens in 37. So that means for each 7, we subtract a 7. We're back to Monday. So after 35 days, the day of the week is still the same. And now, so we get rid of 35, we have minus 2 days. You can say it's just as though it was minus 2 days, which means that Pat's birthday is Saturday. But we don't really need to know what Pat's birthday is, because we're looking at Julie's birthday. So, and then after that, we have minus 67 days. So we have 7 times 9 is 63, which means we have to subtract 4 days. It's the equivalent of subtracting 4 days, which is a Tuesday. Since 6 minus 4 equals 2, and Tuesday is the second day of the week. Which means that Julie's birthday is on a Tuesday for the current year. All right, do you guys understand? All right, let's move on. plus a charge of $5 the kayak. The kayak is $5 per hour, and the paddle is P dollars. For a 3-hour rent, the total cost is $30. 3 hours. We have 3 times $5 plus P dollars equals $30. Cost of a 6-hour rent. 6-hour rental. So we don't really need to know what P is. All we need to do is, since it's 3 more hours, we just have to add another 3 times $5 per hour. Because since the paddle is a fixed fee, we already have the paddle in here, we don't need to add it again. And since we already have the 3-hour part, the 3 times $5 per hour, that's for 3 hours, the kayak fee. And if we add another 3 hours of the kayak fee, then we have 6 hours of kayak fee. Which means that we get $30, this part, plus $15. All right. Next question. And 72. So we're just looking at common factors. We can just prime factorize them. And we look at what prime factors do they have in common. So I'll show you what I mean. So we can, how can we prime factorize 40? Well, we see that 40 is an even number, so we can divide it by 2. Then we have 20. Divide by 2 again, 10. Divide by 2, 5. And 5 is a prime number, so we can't divide anymore. And then we have 72. 72 is divisible by 2, which gives us 36. And then we have 2, which is 18. We have 2, which is 9, 3, and 3. So we see that the common prime factors are 2, 2, and another 2. 3 2s are the common prime factors. So what does this have to do with the problem? Well, we're looking at the common factors. So we have 1, 2, and we have to combine 3 2s together. So you can have 1 2, 2 2s is 4, and 3 2s is 8, which means that there are 8 positive whole number factors. Okay. Now, question 14. Question 14. Harry, Ron, and Neville are having a race on their broomsticks. If there are no ties, in how many different possible orders can they finish? So we have 3 slots. Let's say the first slot, the second slot, and the third slot. So in the first slot, since it's random, there are 3 possibilities of who would finish first. And then, so if we have already predetermined who was first, then we can see that there are 2 more possibilities of second place. And since there is only 1 person remaining after we determine what's the first place and the second place, then the third place we'll already know. So it's just multiply 1. So we have 3 times 2 times 1 equals 6. 6 possibilities. Okay, so now we finished the questions, and now we can talk about last week's questions, like the apple question and the other question, whatever it was called. Yes, the cat question. Okay, 1 sec. Am I sharing? Who is sharing? Oh, okay, never mind. All right, there, so I stopped sharing, and just 1 second, let me just pull, oops. Let me just pull up the thing, the questions. Aha. I think it's this one. Nope, it's not this one. Ooh, where is it? Okay, you know what's? Never mind. Okay, so remember last week when we did like the 2 questions, and there was one question where it was like there were 5 apples and then there were 4 people. No, there was 4 apples and there were 4 people, and you had to give everybody 1 apple and keep 1 apple in the basket. Do you guys remember that one?
Yeah.
Yeah.
Okay, so do you guys have any ideas of how to solve that riddle?
Add
No,
an
it
apple.
wasn't. What?
Add an apple.
No, fine. You're not allowed to add an apple. Oh, it was either 5 apples or 4 apples with 5 people or 4 people. All you need to know is that there was the same amount of apples as the amount of people, and there was 1 basket. Okay, so
You
how do
peel
we
the
do
skin
this?
off of 1 apple and put it in the basket, so it's technically still an apple.
What? Sorry?
You take the skin of an apple, peel it off perfectly, and put it exactly like an apple, so it's technically still an apple.
Yeah, okay. That's a loophole. Yeah, but let's just say that the apples have to be whole apples. Okay? You can't have half an apple. You can't split the apple and say, hey, look, I'm pretending that I'm eating an entire apple, and the basket's also pretending it has an apple in it. You're not allowed to do that.
So you can give them all an apple, but then one girl decides not to eat her apple, so she puts it back in the basket.
You're getting close. Yes, it's something along these lines. Does anybody else have any guesses? No? Okay. Well, so there's you can just do you guys know this thing called sharing? You can 2 people can share 1 apple. Can't they? Yeah, and if you don't want to share apples, then you can have each person has an apple, but one person puts their apple in the basket. It's very quiet. Okay, anyways, so then the other question was the cat question. So we have just 1 sec, okay? I need to find where that thing is. I think it's no. Where is it? Okay, I can't find it. Well, so the other question was that they're in a room. They're in a very small square room. There were kittens at each corner of the room, and there is 1 kitten opposite to each kitten, and there are 3 kittens on the behind each kitten. So how many kittens are there in the room?
A number of kittens.
Yeah, a number of kittens. Okay, yeah, that's an answer. Is there any other answers for the amount of kittens? Lots of cats. Yeah, lots of them. It's totally not 4 kittens, right, guys? Okay, so let's draw it out. All right. So 1 sec, I'll share my screen and let's draw it out how it would look like. So we have, so in a square room, we have 4 kittens, and there were 3 kittens opposite to it. So where can the 3 kittens opposite to it be? Let's see. We have 1, 2, 3 kittens opposite for this kitten. 1, 2, 3 kittens opposite for this kitten. 1, 2, 3 kittens opposite for this kitten. And 1, 2, 3 kittens opposite for this kitten. All right. So there we go with the opposite ones. And then after that, we have the tail ones. So at the back of their tail, there are 3 kittens. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. And let's just say they're out of the room because nobody said that the kittens couldn't be out of the room. And then for these kittens, we can do the same thing. So basically, like this one's opposite to this, this, and this. And this one has a tail here, and like the 3 kittens are behind it. So which means altogether we have 12, not 12, 16 kittens. But it's asking how many kittens are there in the room. And there are 4 kittens. But there's an even more simple way of looking at it. So we have a small room and we have 4 kittens. So each kitten, there are 3 kittens opposite to it. So we have that solved. Wait, 1 sec. Yeah, you said 4 last time, exactly. You're right about the 4. So then, like, if the kitten's tail is going this way, there are 3 kittens that's behind its tail, and same as the other kittens, whose tails are on each other. Yeah, so that's for that question. And I'll just stop sharing right now, and I will find another problem. And you guys can talk while I am looking for the other problems. Okay, this one. All right, I've got another problem so that you guys can think at home. So, first off, clear. And then we have 9 dots. And for these 9 dots, you have to draw a line without picking your pin. You have to, wait 1 sec. I just need to find what it was. All right, so make a square with 9 dots in a square pattern and connect across all the dots with 4 straight lines without taking your pencil off the paper. So you have to cross all 4 of them. So like, for example, I just did this, this, and this. That's not the way you do it, but just some pointers. So how do you draw through all of them? How do you draw through all of them without taking your pencil off in 4 moves? Like this is 5 moves. I got through all of them, but that's 5 moves, so that doesn't count. So do you guys have any ideas? You guys can annotate on like my paper on my whiteboard. You guys can open like your annotating things and just draw on this board and try. Or maybe
Well,
you
they
guys,
never said what counts as a move though.
huh?
They never said what counts as a move though.
Moves? Oh, I mean, not moves. So you have to draw 4 straight. How do you get through all the points by drawing 4 straight lines without taking your pencil off? Yeah. How do we do this? Do you guys want an answer? Okay. Well, you guys can think about this at home or look up answers on the internet at home. I can't stop you, so you guys can do that yourselves. Yeah. All right. It's 2 o'clock now, so that means we can end today's class here. All right. All right. Goodbye. Goodbye, guys.